Hey guys, this is Miss Carasales. Last week we got into functions and we really got into discrete functions as far as domain and range goes, listing them out, evaluating all of that good stuff. This week we're getting more into continuous graphs and seeing how the domain and range works for those. So first thing we're going to look at is the domain. This is the boundary from left to right of the graph. So where does it start? Where does it end? What is my most negative to my most positive point on the x-axis? So when we write that, notice we have a squiggly bracket, x, colon, and then lowest to highest, and I'll look at that more in a little bit. So we are going from left to right, not from right to left. Okay, so just be aware of that, left to right. So if our picture on our graph happens to extend past the number line, we just make the assumption that it is going towards positive infinity and towards negative infinity because we can't actually see the start and end point. So next we have our range, which is on our y-axis. So the boundary from bottom to top of the graph, where is the lowest point to the highest point. Okay, so we want to know how far we climb and then how far we're dropping, but still we start bottom to top. Just like on the domain, we go from lowest to highest, same thing, lowest to highest. And again, if we extend past, then we have to make the assumption that we are going to infinity or towards negative infinity. So we're going to look at four graphs and see how this works. So our main goal is to box in the image that is on the graph. Looking at the coordinate grid, we're gonna actually box in this image. So the goal is to box in the image. So we just kind of take, and you can take sticky notes, you can take a colored pencil, a marker, whatever you want, but we just mark out the sides, so domain and domain. So how far left and how far right, where does my graph start and where does it stop? And then we look at our range, so how far from the top and how far from the bottom. So we've boxed in this image. So now we're starting left to right. So if I start from this low point, which is -2 on the x-axis, and I go all the way over here, which is about 5 on the x-axis, then my domain is all x values, colon, -2 less than or equal to x less than or equal to 5. This should look a little familiar because it is like inequalities. When we go to graph an inequality on a number line, if there's an open circle, we use just a less than. If it's a closed circle, it's a less than or equal to. So that's why we go from lowest to highest. So now I'm gonna look at my range, start from the bottom, scan it up to the top. So my range goes from all y values, colon, -4 is my lowest, which is less than or equal to all the y's in between, which is less than or equal to 4. So that's all we're saying. We're saying that this picture has a point on the y-axis. It's got a point anywhere from the -4 to +4. So again, think back to inequalities, open, closed circle, all that good stuff. And that's pretty much it. It is it's super new, so it's just something to get used to, but it'll get easier as time goes on. So here we go. Let's look at a graph that has an open circle and a closed circle for the ends. So again, our range is from the top and the bottom. So we've already boxed in the top and bottom. So now we want to box in the sides, left to right. So notice my range, I didn't go to the point, I went to the curve, so the lowest part of the graph. So the whole graph needs to be in the box. You cannot leave off part of the graph. You want the whole thing in there, okay? And that tells me, so going left to right, we start with domain. So left to right, I have all my x values are between -1 less than or equal to x less than or equal to 6. And I said less than or equal to. I meant -1 is less than x, which is less than or equal to 6, because that was an open circle and then a closed circle. So now my range, starting from the bottom of that curve to the top with the closed circle. So my lowest the lowest part of my graph to the highest part. This is all y values from -3 less than or equal to y, which are less than or equal to 5. The reason why we put less than or equal to on that curve part is because technically it is a closed circle. It is actually bouncing off of -3 and going towards the top. So -3 is included. Okay, next, what happens if we have a graph that looks like this? So really, when we go to box this in, we only have a top portion. Like, we can only box in the top. The reason why is because the whole thing continues downward. And then these lines are extending slightly like this. So they are actually going out left to right for however, who knows how long. So we don't have a lowest left to a lowest to highest right point. We just have every single number. The way we write this is our little double R symbol, or all real numbers. Negative infinity less than or equal to x, which is less than or equal to infinity. So the easiest way to write that is just all real numbers. Every single real number is included on the x axis. Okay, and then as far as my range goes, if I look, I do have a highest point. I don't have a lowest point, so I don't have a number to start from. So I'm just gonna put that y is actually less than or equal to 4, because every single y value underneath 4 is included on this graph. And last, we're gonna look at another one similar to this. So this is the same thing, but it just shifted to the side now. So really, we only have a domain. We only have this left part that we can cover up. It's continuing on towards the right, towards the positives. And of course, again, it is making that extension outwards. So it's going top to bottom as far as this graph wants to go. So for this domain, we do have a starting point. Our lowest x value is -2, which is less than or equal to x, meaning all x values are bigger than -2 on this graph. And then of course, just like the last one, now we've switched. My range is now all real numbers because it's every single y value is included on this graph, okay? And when you say every single one is including, that means that for every y value, I have a corresponding x value, and vice versa. For every x value bigger than -2, I've got a corresponding y value. So I have a point on this graph, okay? And that is it. You do have some practice to do. You do have a quiz, so good luck on that. Be sure to rewatch this video if you need help, and then message me any questions. Bye, guys.